The two elements that I have been selected to do are Flerovium and dysprosium. I'm Joey Kilgore, also known as Robert Kilgore. So let's get right into it. So Flerovium is the 114th element. Its symbol is Fl, and its atomic weight is 289. It was discovered in 1999 by the Joint Institute for Nuclear Research in Dubna, Russia, and they've discovered a lot of elements also. It was discovered by George Flevour, which you can actually see in the name. It's only produced in labs by bombarding plutonium with calcium ions. They get them up going in very fast speeds, close to light speed, and then they just slam them together and see what happens. And whenever they slammed those two together, they got Flerovium. The only known isotope of it is 289, and it has a half-life of 2.1 seconds. So if you notice, the only known isotope is 289, and that refers to its atomic weight, which is why the atomic weight of Flerovium is 289. It has an unknown melting point, boiling point, and density. This is due to its really low half-life, so unless they have a large sample size, they don't have enough time to test it, because every about 2 seconds, they only have half of what they did previously. It is a solid at room temperature, and it is radioactive. So here's Flerovium's atomic structure. It has 114 protons, and then to counteract that, it has to have 114 electrons, and then it has 175 neutrons, which when added together get you the previous atomic weight of 280 or 89. Alright, moving on to the next one. The next one is dysprosium. Its atomic number is 66. Its symbol is dy, and its atomic weight is 164.93. It was discovered in 1886 by Paul-Émile Lecoux de Bosbardran, and it is a metallic and shiny metal, which you'll see later in the picture and video. It actually has very little use in its pure form because it's reactive with water and air, so anything that we would use it for in its pure form would react, and it would just not go well for us unless we're using it in some sort of water and airtight chamber. It bonds with neodymium to make really strong rare earth magnets, which you may have either played with or seen used, and they're very, very strong magnets. This is not radioactive, and it's solid at room temperature. So there's a picture of it. You can see how it's silvery and metallic looking. It's very shiny. So here's a video about a guy with a dysprosium sample.
Hello my fellow Americans, the real Damon Jackson here, and today I was going to show you my dysprosium sample. I actually just got it today. It warns you because dysprosium salts are mildly toxic, but for the metal the data is inconclusive, so they haven't really tested the metal yet for its toxicity, but it's probably a little toxic. So if you take it out, look at that. Beautiful dysprosium crystals. It's actually like a flaky, shiny metal, kind of golden colored actually. If we flip it over, we have the base. However, they crystallized it. Is crystallize a word? I don't know. I'm kind of tired today. But basically, dysprosium is used in nuclear reactors as a neutron absorber. So I guess it can absorb a lot of neutrons. And it's also used in laser parts, which I don't intend to do that with it. I just have it because I didn't have it before, and I needed a dysprosium sample. So this is symbol dy on the periodic table. It's pretty neat to look at. I don't know if you can see it very well, but it's kind of like a flaky metal. It has, get the camera. Maybe if I put my camera far away, you can see the details better. See that? It's got like crystals coming out of it. I don't know how to describe it. It's kind of cool. It's a rare earth metal. I don't have very many rare earth metals just laying around like this.
So that was a video of a guy that has a dysprosium sample. So here is dysprosium's atomic structure. That's what it looks like. And it, of course, has 66 protons because that's its atomic number. And to balance that out, it has 66 electrons. And then whenever you add the 66 protons and 97 neutrons, you get its atomic weight of about 163. And here are my works cited. It has the 3 different websites that I've used if you would like to check those out and learn more on your own. Here's the one for Flerovium, and I believe those are both for Flerovium, and that one's for dysprosium. Thanks for watching.